limit of function. At first, I recommended you keep this in mind. If you want to calculus more better, then mind it derivative and integral are names given by some special kind of limit. So, limit is actually most central of calculus, and calculus studies about change. If you tells me what happened the function y equal to fx, then what happened? How does y changes when the independent variable x changes? How the function value changes with change of independent variable? Okay? Actually, calculus deals rate of change for unit time. Actually, calculus arose because pupil wanted to understand motion. If you look history, calculus came when pupils started talking about velocity of object at a given time. Okay? Alright. So, people like Newton and others realized that if you want to look how a particle is moving, I can draw a graph. Let's see the graph. This is t. I can put here function of t, because you can understand it easily. You can always consider a time. When you still at a time t equal to 0, then you start to moving. So, as you move, distance changes where time flows. That means you cover more distance. Okay? As for example, let a train start from 12 o'clock from Bardhaman station and has to go towards Sealdah station. Since it start to move 12 o'clock, then 12:30 it is next station, and 12:40 it is some other place, and 12:50 it is some other place, so on. Okay? Now, what will be the graph as a train start? It will be increasing at first. So, train moves increasing in continuous time. Now, my question, what is the velocity at 1:50 p.m.? This velocity can come down. Okay? Because it has stopped some station and it could be 0 after certain time, means it will be reach the station. This is the graph of this motion. Okay? Well, this is the time t naught. Now my question, what is the velocity at given time t naught? Let s equal to distance f of t naught. Let after small amount of time del t, s dash will be the distance f of t naught plus del t. Okay? So, what will be the average distance? The average distance will be f of t naught plus delta t minus f of t naught over t naught, and this is equal to delta s over delta t naught. So look at the distance few seconds before and few seconds after, and 1:50 p.m. the train did have the velocity. If you want to know actual velocity, then the distance which I covered a small time period, then you make this time period as smaller. If this time period goes towards 0, then you will get actual velocity. Okay? And this process Newton gives the notion of the limit. That means limit delta t tends to 0, delta s over delta t, which is equal to Vt, means actual velocity. Okay, and this is the notion of limit. Well, all right. Now let's see this concept of limit by mathematically. Let y equal to function of x, where f defined from real line to real line. Okay, and when x goes to a, then what does y goes to? This is my question. But at first question, what is the meaning? X goes to a. Let's see the picture. This is real line, this is a. X goes to a means x can approach from either this right side or left side or both. Okay. Now what do you mean? Where does y goes? If y values goes a particular value called L, that means y equal to fx tends to L when x goes to a. Then we can say this value L is the limit of the function. Okay, all right. If I see the graph, here x-axis, this is a. Here x need not be defined at a. X did not be defined at a. Okay, this is fx. Since x need not be defined a, then the value of function does not exist at the point a. This is the graph of fx, and this is the limit L. Whenever I find such x such that fx is very near to L, either this side or both, then I obviously able to tell you corresponding x near to a. Okay, that means if fx is near to L, you have to show x is near to a. That means when fx goes to L, then that means fx goes to L when x goes to a. Okay, all right. So the definition of the limit by epsilon delta definition is, if you give any epsilon, let this is epsilon distance, then this would be L minus epsilon and this would be L plus epsilon. Okay, no matter what epsilon you give, and for this epsilon I can always specify a distance around L. Let this distance be delta distance, this is delta distance, let this is delta distance, then this would be a minus delta and this would be a plus delta. Okay, if you pick an x within this interval a minus delta, a plus delta, then I can guarantee for corresponding this x, you always get fx within this interval L plus epsilon, L minus epsilon. Okay, and usual definition is, given any epsilon greater than 0, there exists delta greater than 0 such that distance between x and a always less than delta, that imply distance between fx and the limit point always less than epsilon. That means if you pick one x value between this interval, then I can guarantee you this value always lies this interval, and this is the definition, actual definition of the limit in mathematically. Okay, well, let's verify this definition by an example. We have to show limit x tends to 2, x cube equal to 8. What is definition of limit by epsilon delta definition? For all epsilon greater than 0, there exists delta greater than 0 such that for all x, if x minus 2 less than delta where x not equal to 2, then modulus of x cube minus 8 less than epsilon. First step, find delta. Now you start from this term xl, modulus of x cube minus 8 less than epsilon, and try to find such delta. Okay, x cube minus 8 modulus, and this is equal to x cube minus 2 cube. Okay, this we can write modulus of x minus 2 plus modulus of x square plus 2x plus 4. And look, you have got a modulus of x minus 2, because you know by definition modulus of x minus 2 strictly less than delta. Now we need to control this term. Okay? By triangle inequality, we can write less than equal to modulus of x minus 2 modulus of x square plus 2 times modulus of x, absolute value of x, plus 4. Okay? This is equal to x minus 2, and absolute value of x square always equal to x square because it is positive, plus 2 times absolute value of x plus 4. Okay? And remember, x is very close to 2. Then we can assume distance between x and 2 is less than a. Let's see what have assumed. Let's assume distance between x and t less than 1. Here you could have to choose 10, 5, etc. Not restriction of 1. Okay? That imply from this line x minus 2 lies minus 1, x minus 2 plus 1. That imply 1 less than x less than 3. From this line we can write absolute value of x strictly less than 3. Okay? Then this would be x cube minus 3 equal to modulus of x minus 2. Since absolute value of x less than 3, then x square equal will be 9. This is 9 plus 2 times 3 plus 4. This is strictly less than equal to. Okay? This is strictly less than equal to 19 modulus of x minus 2. And remember, by definition, distance between x cube minus 8 always strictly less than epsilon. That means we can write it less than epsilon. From this line we get x minus 2 strictly less than epsilon over 90. And this is our delta, which we want. Okay? Well, and remember, at first you chose modulus of x minus 2 strictly less than 1. So, step 2 is here delta not only epsilon over 19, delta can be 1. That means we choose delta equal to which is not to be epsilon over 19, also not to be 1. delta equal to minimum of epsilon over 19 1. Okay, have you understood? Then if 1 is here and epsilon over 19 here, then minimum will be epsilon over 19. But if 1 is here and epsilon over 19 here, then minimum will be 1. Okay, well, now look, the absolute value of x minus 2 in definition always less than delta. That means if we choose this interval, then since absolute value of x minus 2 less than delta, here delta equal to minimum of epsilon over 19 and 1, then this value, absolute value of x minus 2 always less than 1. That imply from this relation modulus of x strictly less than 3. Okay, from this line absolute value of x cube minus 8 equal to less than absolute value of x minus 2 and times x square plus 2x plus 4. Okay, and since from here absolute value of x strictly less than 3, which I have calculated here by putting this point, and I have get 19 x minus 19 times absolute value of x minus 2. That means this will be absolute value of x minus 2 times 19. And remember, absolute value of x minus 2 strictly less than epsilon over 19. That means this is strictly less than epsilon over 19 times 19, which is strictly less than epsilon. That means absolute value of x cube minus 8 strictly less than epsilon. And this is our proof. Let's see again what we have to prove. And I have done. Okay. Well, let's see one more example. Fx equal to x sine 1 over x, where x belongs to real number. And this function is called topological sine curve. This function is not defined as at x equal to 0. But what would happen if I take the limit of fx as x tends to 0? Limit x tends to 0, what would be the value of fx? Let's see the picture. This is oscillates function, and this function is oscillate like this, and this oscillate is very fast at x equal to 0. This is very beautiful function. This is the picture of x sine 1 over x, and this value is equal to 0 because we all of us know sine 1 over x vary from -1 to 1. Then this will be 0. If we want to verify this function by epsilon delta definition, then what would be? Take epsilon be any positive number. Since here the L equal to 0, that means absolute value of fx minus 0 equal to x sine 1 over x. This is less than equal to absolute value of x into times sine 1 over x, and this value always less than equal to 1. That means this is less than equal to modulus of x, and this function always less than epsilon. That means here what is the delta? Delta equal to just epsilon. That means since modulus of x less than epsilon, then here delta equal to epsilon. Okay? Our proof have done. Okay? Well, now let's see one more example. Define a function f from open interval 0, 1 to r such that f of x equal to half if x belongs to 0 half and f of x equal to 1 if x belongs to closed half open 1. This is the picture. In the interval 0 half, the value of the function half, and in the interval closed half to 1, the value of the function is 1. Okay? Then the function has limit at each point of 0, 1 except half. What do you mean? If limit fx equal to L when x goes to half, this means for all epsilon greater than 0, there exists delta greater than 0 such that x belongs to open interval 0, 1 and 0 strictly less than absolute value of x minus half strictly less than delta, which imply absolute value of fx minus L strictly less than epsilon. Okay? And when limit at x goes to half, the value of fx does not L means here for all epsilon greater than 0 there exists delta. Here if there exists an epsilon greater than 0, for all delta greater than 0, x belongs to open interval 0, 1 and 0 strictly less than x minus half strictly less than delta, but fx minus L greater than equal to epsilon. This is very important thing. See what is the difference here for all epsilon, and here if there exists one epsilon. Okay, and here for all epsilon if there exists n delta, here it is satisfied for all delta. Okay, all right, let's see this example. Let's choose epsilon equal to 1/4 and let delta greater than 0. Since here for all delta, so we take any arbitrary delta, and we have to choose 2 point x1 x2 belongs to open interval 0 1 here. This is half, this is 0, this is 1. Let this is half minus delta and this would be half plus delta. Okay, let's choose x1 x2 belongs to open interval 0 1 such that let x1 belongs to half minus delta comma half, that means x1 would be here, and x2 belongs to half comma half plus delta. Okay, from this relation we can write absolute value of x1 minus half strictly less than delta, and from this relation we can also write x2 minus half strictly less than delta. Okay, and what is the value of fx1? Sorry, fx1, the value will be half. See the defined function. Are you getting my point? Why half? And what is the value of fx2? The value will be 1. fx2 equal to 1. Okay, therefore absolute value of f of x1 minus L plus, we can write L minus fx2, because here the absolute fx2 minus L and L minus fx2 is same. Then by triangle inequality it will be, here notice this is greater than equal to, because triangle inequality is modulus of a plus absolute value of a plus b strictly less than equal to modulus of a plus modulus of b, but here reverse, so it is strictly greater than equal to absolute value of f of x1 minus L plus L minus f of x2. Okay, from this line this is strictly less than equal greater than equal to f of x1 minus f of x2. Okay. And the value f of x1 half and f of x2 1, that means 1 minus half, that means this is greater than equal to half. Since from this line absolute value of f of x1 minus f of x2 strictly greater than equal to half, that imply either absolute value of f of x1 minus L greater than equal to 1 over 4, or absolute value of f of x2 minus L greater than equal to 1 over 4. Okay, that means it satisfies this relation. So at the point half, the limit does not exist. Are you getting my point? Okay. Now my question, what is the meaning limit extends to plus infinity, the value of fx equal to some finite value? Does this have any meaning? If I make x very large, then the functional value is smaller, smaller and smaller. This is the meaning of this condition. Let's see one example. Let x tends to infinity, 1 over x square equal to 0. Prove it. This meaning for all epsilon greater than 0, there is capital N greater than 0, such that if x greater than capital N, then absolute value of 1 over x square strictly less than epsilon. Part 1. Find such n. Absolute value of 1 over x square strictly less than epsilon, that imply 1 over x square strictly less than epsilon, that imply x square greater than 1 over epsilon, that also imply x greater than square root of 1 over epsilon and x less than minus square root of 1 over epsilon. Okay? Well, and these can be capital N. Now let's see actual definition. Part 2. Let epsilon greater than 0 and let n equal to 1 over square root of epsilon. Okay? Suppose x greater than n, where n equal to 1 over square root of epsilon. That imply x square greater than 1 over square root of epsilon whole square, that is equal to 1 over epsilon. That imply 1 over x square strictly less than epsilon. And this value is always positive. So, if we apply absolute value, then no matter. And this is our proof. Okay? Well, now let's see what is the difference between sequence and function. Okay? Let an equal to 1 over n square, where n belongs to natural number. This is a sequence. This is look like 1 over 2 square, 1 over 3 square, so on. Let's draw the picture. This is n axis, okay, and this is an. Here 1, 2, 3, 4, 5, 6, 7, so on. Okay. Here, since here n for 1, this is the value 1. That means here the point. For 2, 1 over 2. One over 2 square. This is the point. Here the value. For 3, 1 over 3 square. This is the value. 1 over 4 square. This is the value. 1 over 5 square, so on. This is a picture of the sequence 1 over n square. If we connect then this would be function fx equal to 1 over x square, and this would be just x axis. Okay? Well, this is the connection of function and sequence. Limit n tends to infinity, 1 over n square equal to 0. That means when n is very large, then the terms of the sequence close to 0. Well, then this is also true. Limit x tends to infinity, 1 over x square equal to 0. Here just 1, 2, 3, so on. Here x. Okay. So, if a sequence has a limit, then the function also limit. Let's see, draw limit of the sequence again. I have discussed in my previous video what is the limit of the sequence. At first I recommended you please see this video. Just recall. Limit n tends to infinity. Limit n tends to infinity. Xn equal to L. That imply given epsilon greater than 0, there exists n naught belongs to natural number such that n greater than equal to n naught xn minus L strictly less than epsilon. Okay, let's see the picture. This is L, this is epsilon band, that means this is L plus epsilon, this is L minus epsilon. Here x1, suppose here x2, x3, x4, x5, x6, x7, so on. After n not equal to 5, all xn lies these two epsilon band. Okay, this is the limit of the sequence. If we draw this term, let's see, after n not equal to 5, all terms of the sequence lies these two epsilon band. So, if the sequence convergent, this is also bounded. Okay. Now, if a function has a limit, that means if limit x tends to infinity, fx equal to L, then this is always true. Limit n tends to infinity, fn equal to L. Okay. But converse is not true. If a sequence has a limit L, then any function joining those points maybe cannot be limit point. Okay, let's see the picture. This is 1, 2, 3, 4, 5, so on. This is n axis and this is n axis. This is the limit L. That means here the epsilon band, L plus epsilon, L minus epsilon. This is the sequence. This look like, that means sequence has a limit L because after term n greater than equal to n naught, all terms of the sequence lies this to epsilon band. If we connect them, this is the function. This function cannot be any limit. So, converse is not true. If a sequence has limit, then function may not exist any limit. Okay? Alright.